Okay, now we're going through question 3 of the 2022 O-Level A Math Paper 1. Okay, for question 3, the first part is just asking you to divide one polynomial by another polynomial. Okay, so this just requires you to do long division. So if you recall, long division, whether it's for polynomials or just regular whole numbers, right? All you have to do is first write down the dividend. So that is the first polynomial. 2x cubed plus 5x squared plus 6. Okay. And then you divide it by the divisor, and that will be x cubed plus 2x. Okay. So maybe I'll just label the different parts. So it's just good to know what these parts refer to. So this is the divisor. This is the dividend. Okay. And then later on, the part at the top will be the quotient. And the remaining part at the bottom will be the remainder. Okay. So how do we do long division? First, you just focus on the first term, okay? So in this case, it's 2x cubed, right? So you arrange all your terms in decreasing order of the power. Okay, so we start with the highest power term first. So 2x cubed. We divide that by x cubed. Okay? So 2x cubed divided by x cubed will give you 2. Okay? Then again, just like how you do your regular long division for normal numbers, it will be you will multiply 2 by the entire x cubed plus 2x. Okay, the entire divisor. So 2 times x cubed plus 2x will be 2x cubed. Okay, and then 2 times 2x will be 4x. Okay, plus 4x. So this whole thing, right, you're gonna subtract from the top. Okay. So maybe I'll rearrange this a bit just to show you the terms that are missing because you might get confused, okay? Recall that the term at the top right here, this is 5x squared. So this is the x squared term. It doesn't match with the plus 4x. So the x term is actually missing in the original polynomial, in the dividend. There's no x term. Okay, so when you subtract the 4x right later, you are getting 0 minus 4x, okay? So I'm just gonna write it this way so you can see what corresponds to what. It's a bit clearer. So 2x cubed minus 2x cubed will just be 0. Okay. And then 5x squared, we are not subtracting any x squared terms, right? So we'll have 5x squared remaining still. And then we get 0 minus 4x. Even though this is plus 4x, right? Remember, we are subtracting it. So we are subtracting positive 4x. So we'll get negative 4x. Okay, plus 6. Okay, do we continue? That's the question. So how do you know when to stop? You don't have to force this part at the bottom, which is the remainder, right? This is the remainder, okay? You don't have to force it to be 0, okay? You don't have to keep going until this is 0. How do you know when to stop? You stop when the power of the divisor is higher than the highest power of your remainder. Okay, this is when you know how to stop. Okay, so this is basically the long division you have to do for this question. So that's why it's only worth 1 mark. It's not that long. So what is the answer when you divide this? Okay. So 2x cubed plus 5x squared plus 6 divided by x cubed plus 2x, okay, is equal to, the answer is not just the remainder, okay? So the answer is always the quotient, which is 2, plus the remainder over the divisor. Okay, so please remember the general formula of the final answer. So basically, okay, let me just write the general formula, okay? When you have a dividend, okay, divided by the divisor, your solution is the quotient plus the remainder over the divisor. Okay, so please remember this general formula. So your answer is this. Okay, part B is now asking you to express this expression in partial fractions. Usually the part B will be related to the part A. So let's just compare, okay, what we have. So you'll see that this is essentially just the left-hand side of what we just had, right? So when they ask us to express that expression, that fraction in partial fractions, they want us to convert this right-hand side to partial fractions as well. Okay, so this right-hand side is basically just one step closer to getting the partial fractions. So we see the 2 is already a whole number on its own. So when we're trying to convert this right-hand side to partial fractions, we don't have to bother about the 2 yet, okay? The 2 will just come back at the end, but in the process of getting the partial fractions, we can ignore the 2 in the meantime. So now how do we convert that remaining part, okay, the polynomial part, so this one, to partial fractions? Okay, let's figure that out. So I'm just going to transfer that fraction first. So the remaining part is this, right? 5x squared minus 4x plus 6 over x cubed plus 2x. Okay. How do we convert this to partial fractions? Okay. First of all, before you convert something to partial fractions, before you apply the formula that you have to memorize, right? Before you even think about that, there are two things you have to make sure of, okay? One, you have to make sure your fraction that you have with you is a proper fraction. How do we know that something is a proper fraction? The way we check is by verifying that the highest order, okay, the highest power of the numerator is lower than the highest power of the denominator. If it's the same power, right, let's say both of them are cubed, that is still an improper fraction, okay? Which means we still need to factorize something out. Not factorize, but we have to convert it to this form. So we have to take some whole number out still. Okay, there's still some whole number, like this 2, that we can take out. Okay, so, but in that case, we already took out this 2 from the original fraction, right? So that's how you see it. That's why initially they were both the same power in the numerator and denominator, a same highest power of 3. But then, after taking out the 2, it became a proper fraction. Okay, before it, it was an improper fraction. So now that we have a proper fraction, okay, because the numerator's highest power is 2, which is lower than the denominator's highest power that is 3, we can look for the second point, okay? So that's the first thing you need to make sure of. The second thing you need to make sure of is that your denominator is fully factorized, which in this case it's not, right? So let's fully factorize it first. The numerator doesn't have to be fully factorized, okay? You can just leave it as it is. Only the denominator has to be fully factorized. So you can take x out, we'll get x squared plus 2, okay? Now that we have these 2 points settled, then we can start to think about the formula. So let's recall the 3 formulae you have to remember for partial fractions. There are different cases, and you have to identify which case is applicable to the question you are working on. You need to see which formula you're supposed to use. Okay, so which formula you're supposed to use depends on what type of factors are present in the denominator. The first case is when you have distinct linear factors. What does that mean? Okay, distinct just means that the linear factors you have are different from each other. Okay, and a linear factor is just a factor where the highest power of x is 1. So you can see, for example, in the example I showed for case 1, right? The factors in the denominator are x plus 2 and 3x minus 1. You can see that for both factors, they are different from each other. That's why they are distinct. And they are both of them have the highest power of x as 1. Okay, it's 3x to the power of 1 for the second factor, and for the first factor is x to the power of 1. So they are both linear factors. In that case, all we have to do to get the partial fractions is to literally split up the 2 factors into 2 fractions like this. So each fraction has one of the linear factors as the denominator. Okay, and the numerator will just be a and b. Okay, so any just constant number in the numerator. Okay, case 2 is when you have repeated linear factors. So similar to case 1, the factors are still linear, okay, for just like case one, but they are repeated. Okay, so okay, for example, right, let's look at the example for it to look more clear, okay? So when you repeat something, it means you are multiplying it by itself. Okay, in math, that's what repeated factors mean. Okay, so if you have one linear factor but you repeat it, you multiply it by itself, it isn't linear anymore. Okay, technically, because you are just multiplying it by itself. So you get like a quadratic. So that's why for case two, if you focus on the x squared part, x itself is linear, right? Okay, because the highest power is one. But when you have a repeated factor of x, so x multiplied by itself, you get x squared, which is now no longer linear. Okay, but the original factor, just x, was linear to begin with. So you can see what happens. You have to first get one fraction, a over x, okay, the linear part, plus b over x squared, which is the factor that you see here, the repeated part. Okay. Then you can see for 3x minus 1, it's just a linear factor, right? It's not repeated. Okay, so that's why for the 3x minus 1 part, it's just, we just have to include it one time. It's just c over 3x minus 1, just like the case one. Okay. So take note, I gave a second example just to show you how it might look like if 3x minus 1 was a repeated factor instead. So you can see again, here, now x is just a linear factor. It's not repeated. That's why you only have a over x to represent that part. Okay. And then for 3x minus 1 whole thing squared, now you have two fractions that come out of that factor. Okay, you have the first fraction, the denominator will just be 3x minus 1, not repeated. Okay, just a linear factor. But then you have to have another fraction. You have to add another fraction where it's the repeated linear factor as a denominator. Okay, so 3x minus 1 whole thing squared. That's the only difference. Okay, case 3, you have irreducible quadratic factors in the denominator. Okay, so again, for the factor x plus 1, by now you should be able to identify that as a linear factor, right? It's not repeated, okay? So it's just a linear factor x plus 1, so we just have to write it once. So the fraction that comes out of it is a over x plus 1. But then you have this factor x squared plus 2. Okay, this is not a repeated linear factor, okay? Because the square is not outside of the entire bracket x plus 2. It's only on the x. Okay, so this is its own category. It's called the irreducible quadratic factors. When a factor is irreducible, it means it can't be further factorized anymore. You cannot factorize x squared plus 2. Okay, so that's why when that happens, the fraction that comes out of it will be bx plus c over x squared plus 2. Okay, so you don't have to repeat this twice like you have to in case 2. You just have to write it once, but the numerator is no longer just b or a. Okay, it's no longer just a number. It's bx plus c. Okay, so you have an x term in the numerator as well. So just remember that. And take note, one common mistake that students make is when they see, for example, a factor x squared minus 4, okay, they might think this is an irreducible quadratic factor, but that is not the case because it has to be plus. When it's minus, remember from your algebraic identities, you can actually further factorize this. So this is not irreducible, okay? It can be further reduced. Remember, a squared minus b squared equals to a plus b, a minus b. So this can actually be further reduced to two linear factors, distinct linear factors, x plus 2, x minus 2. Okay, so just take note of the difference. So I'll show you the summary here in case you want to take note of it. So you can take a screenshot of this screen just for you to memorize, to help you memorize like the different cases for partial fractions. Okay, so now let's go back to the question. Now that we've revised the different cases that you have to know for partial fractions. So let's analyze what kind of factors we have here, okay? So there are two parts here, two factors. This is a linear factor. Okay, it's not repeated, okay? It's just a linear factor. So it's not repeated, so we only have to come up with one fraction from this factor. This part is irreducible. Okay. So take note, again, let's just recap. For the linear factor, it's just a over that factor. It's very easy. For the irreducible one, we have to write bx plus c over the irreducible factor. Okay, so now let's apply that to the question. So that will basically be equal to a over x plus b over bx plus c over x squared plus 2. Okay. Okay, now notice that this whole thing has been an equation the whole time. Okay, so from the beginning, the first expression we had, which was this one, all the way to this last expression that we have so far, they are equal. Okay, it's all equal signs connecting them. So that means they are the same. So if they are the same, right, let's try to make them look more similar to each other because now they are looking a bit different. So to do that, we can try to combine the two fractions into one first. Okay, so to combine them, you need to have a common denominator, right? So to do that, we can have this. We can multiply the first fraction by x squared plus 2, both the numerator and denominator. And similarly, we can multiply bx plus c and also the denominator later on by x. Okay, so we'll have this x times x squared plus 2. Okay, x times x squared plus 2 is equal to x cubed plus 2x, okay, when you expand it. So we know that these two are the same. Okay, these two denominators are the same. When that's the case, and also both fractions, the initial and the final fractions are the same, and the denominators are also the same, we know that we can conclude that the numerators must also be the same, right? So basically, this numerator and this numerator, they are exactly the same. When that's the case, we can move on to comparing the coefficients for us to figure out what A, B, and C refer to. Okay, so let's compare the coefficients. So maybe we can start with the constants first, okay? Okay, the constant, we compare the coefficient of, okay, the constant term is basically the x to the power of 0 term, okay? Because x to the power of 0 is just 1, right? So there's no x in that term. So basically the constant. Let me just write constant as well so there's no confusion. So the constant term in the left-hand side is 6. You can see it's 6, right? So 6 must be equal to the constant term on the right-hand side. So where is the constant term here? Okay, again, just focus on the numerators, okay? A times x squared will give us ax squared, which is an x squared term. A times 2 will give us 2a. There's no x, right? So that is a constant term. Okay? And there's no other constant term present in the numerator. All of them will give us either x squared or x terms. Okay? So now we can solve for a. A must be equal to 3. Okay, so we've already solved for a. Next, the x squared term. Let's compare. Okay, in the left-hand side, it's 5. The coefficient is 5. On the right-hand side, the x squared terms are, okay, ax squared. That will give you one x squared term, so a. And then plus, do you see you can form another x squared term by getting bx times x? Okay, this bx you multiply by x will give you bx squared. That is an x squared term as well. Okay, so plus b. And you know a is already 3, so therefore b must be equal to 2. Okay, if it helps, right, what you can do is to also, you can also expand this if it's confusing, okay, to see like what is the x term, what is the constant, what is the x squared term. You can also expand this to help you out. So this is ax squared plus 2a. Okay, then I'm just expanding the numerator, okay, plus bx squared plus cx. Okay, so therefore you can combine the similar variables. So like x squared, let's combine the terms. So a plus b will give you the combined x squared term plus cx plus 2a. Okay, so you can see where the constant is, where the x term is, where the x squared term is. Maybe it's easier to compare like this. Okay, then lastly, to find C, we can compare the coefficients of the x terms. Okay, on the left-hand side, it's -4. On the right-hand side, it's just C. You can see the x term is just C. Okay, so therefore, C is just -4. Okay, so let's combine everything together. So we just have to put the A, B, and C values into this part. Okay, but recall 2x cubed plus 5x squared plus 6 over x cubed plus 2x, which is the original question. It's not the same as this, okay? It's not equal to this. Remember, we had a part we ignored at the start, which was a 2 plus, right? This is the time to bring it back. Okay, so let's rewrite the question. So 2x cubed plus 5x plus 6 over x cubed plus 2x is actually equal to, remember, it's 2 plus that fraction that we just broke down into partial fractions. Okay, so don't forget the 2 at the beginning. So 2 plus, okay, now we sub the values in. A over x will be 3 over x plus bx plus c. There will be 2x minus 4 over x squared plus 2. Okay. And if you want to, you can also further factorize the numerator. You can factorize 2 out. Okay, the only benefit of doing this is in case the denominator also somehow has the factor of 2, then you can identify that there's a common factor and further simplify. Okay, so that's the only benefit of further factorizing. So this is the answer for this part. Okay, and here's the full solution.